A hot air balloon is 9 meters in radius, assume it's spherical, and contains hot air with a mean density, that means it's not very nice, of 0.95 cubic meters, right? Calculate the lifting capacity in newtons of the hot air, just the hot air, right? If it is surrounded by air with a density of 1.31 kilograms per cubic meters. Okay, all right. So what we're going to do, same thing. It's the same problem that we just did. Only in this case, the buoyant force will be more, right? So here's this balloon. There's going to be a buoyant force acting up on it. There's going to be the force of gravity down, right? The difference between the buoyant force and the force of gravity will be its ability to lift. Okay, so let's figure out the buoyant force. The buoyant force is the density of the fluid displaced, the volume of the fluid displaced times g, right? Well, this is the fluid displaced, right? Okay, the volume of the fluid displaced is the volume of the balloon. So 4/3 pi times 9 to the third. And then g is 9.81 newtons per kilogram. And this will end up being, it'll all cancel out, except for newtons, right? So 1.31 times 4 divided by 3 times pi. Oops, I typed 1.30. I'm going to type 1.31. Pi times 9 raised to the third. Don't square it. All right, times 9.81. All right. So the buoyant force is actually 39,242.5 newtons. So now we got to figure out what's the weight of the force of gravity, right? Well, the force of gravity is going to be m times g. Well, what the heck is the mass of all that air? Well, the mass is going to be the density of the air times the volume of the air, right? Okay, times g. And if you look at this, it's like, the force of gravity on it looks very similar to the buoyant force. And that's because, of course, it's the same calculation, right? The buoyant force is the weight of the air displaced. We're now figuring out the weight of the air inside, which is very similar, except the density will be different, right? Okay, so that equals 0.950. The volume of the air is the same as this volume here, right? So 4/3 pi times 9 to the third. All right, do I have enough parentheses? That's my main worry here. 9.81. Okay, there we go. Okay, so basically I can do the same equation I just did, only I'm going to replace the 1.31 with 0.95. And I get that the force of gravity is 28,458.3 roughly. Right? So that's this force is 28,458.3. And then we can, of course, we want to know the lifting power, right? So that'll be the net force. So the net force is just simply 39,242.5 minus 28. This is the net force, right? 458.3. So this would be the force. If they said you're holding the balloon down with a tie down or something like that, this would be the force we'd have to exert. So I'm going to go that number minus this number. And I get 1074.2 newtons approximately, right? And then, of course, a real balloon you'd have the fabric, the envelope would have quite a bit of weight to it, and then the basket and the fuel and the people and all that stuff, right? Yeah. If you're paying attention to this, do you feel like maybe you could make a balloon formula, right? Because it's this minus this, right? It is the force is it's just B minus force of gravity, right? Which is so B minus the force of gravity is just rho of the cold air, right? Times the volume of the balloon, right? Times G minus rho of the hot air times the volume of the balloon times G, if you're paying attention, right? So doesn't that sort of boil down to like density of the cold minus the density of the hot? Right? Do you think I cheat? Do you think when I solve these problems, I just subtract those densities? It's crazy, right? Ultimately, that's what it boils down to. So if you've solved 100 of these, you get kind of tired of it.